On behalf of the Board of Directors, the staff, and the volunteers of the Museum of Western Colorado, welcome to Dinosaur Journey.
$152 million years ago, dinosaurs hunted on the river valleys of Utah and Colorado's western slope. Now it's the paleontologists who are hunting the dinosaurs. This is the story of Western Slope's own dinosaur journey.
The geologic story and the paleontological story of the Grand Valley is really kind of special in the grand scheme of geology and paleontology. We have things here that you don't find anywhere else in the world. We're one of the very few sites that has record of these small animals of the Jurassic period, the animals that lived alongside the big dinosaurs. And this is the area where Brachiosaurus was first discovered. We also have a wholly new species of Ceratosaurus. We have some of the oldest mammal trackways ever found. And all of that weaves together to form a really, really special story and a big piece of the paleontological story that you just don't get elsewhere in the country.
The treasure trove of fossils in western Colorado did not come about by random chance. The unique geologic history of this area paved the way for fossils to form and for them to be discovered by paleontologists. The oldest rock layers are always found at the bottom, with the younger rock layers stacked on top. Precambrian granites and gneisses are the oldest rock units found in the Grand Valley. On top of this is a gap of missing time called the Great Unconformity, and above this are the geologic formations that make up the Triassic, Jurassic, and Cretaceous periods. This geologic history not only helps to date the fossils, but also helps to determine the environments and climates in which these prehistoric animals were living. The rich fossil resources on the western slope were too impressive to stay hidden for long. Soon after the Grand Valley was settled in the 1880s, fossils drew the attention of paleontologists from museums back east. Elmer Riggs and his assistant, Harry Menke, from the Field Columbian Museum of Natural History in Chicago, were some of the first to explore western Colorado for dinosaur finds. Riggs and his team came to western Colorado in 1900 and began excavation at the site now known as Riggs Hill.
According to legend, on the 4th of July, Harry Menke went prospecting and found what he called, quote, the biggest thing yet. So he comes back to camp and he tells Riggs, hey, this is great, I found the biggest thing yet, we've got to go check it out. Riggs agrees to go and see the prospect for himself. And what he finds is somewhat impressive. There was one very large limb bone sticking out of the side of a cliff at the site now known as Riggs Hill. And so he decided, oh, you know, this is not as promising as the stuff I'm finding at Quarry 12. We're going to finish Quarry 12 and maybe we'll come back. So they went back to Quarry 12. They finished excavating all the things they were finding there. Then they went back to Riggs Hill. And once they started developing that prospect, they realized they had something really special. So what they wound up with was limb bones, pelvis, a number of dorsal vertebrae, lots of ribs, but something that was obviously very, very large and fairly interesting. It was only later that Riggs determined that this was definitely something new. Riggs later coined the name Brachiosaurus altithorax.
The discovery of Brachiosaurus was important at the time because it was the first new dinosaur found in the area, but also because it set the stage for all the new fossil discoveries that would be found decades later in western Colorado. Soon after finding the Brachiosaurus skeleton, Riggs and his team discovered another important sauropod specimen at the location, now known as Dinosaur Hill.
Very late in the season, shortly before they were scheduled to get back on the train for Chicago, probably Menke, Riggs never says, but I assume it was Menke, found what would later become the Apatosaurus collected at Dinosaur Hill across the river from Fruta.
They tell the Apatosaurus was still buried deep in the hillside when they left. Former curator of paleontology at the Museums of Western Colorado, Harley Armstrong, and his team re-excavated Dinosaur Hill in early 1991, almost 100 years later. They're able to get about 20 feet farther into the tunnel with dynamite and recovered several more bones from the Apatosaurus tail. Removing fossils from quarries is a huge task. Scientists have developed tools and techniques to uncover these ancient bones. Every quarry is unique, but the process paleontologists use is the same no matter the location or size of a fossil. Fossils are found during field work, carefully removed and brought to the lab, where they are cleaned and prepared.
To find a quarry, you just start walking in the right formation and look for float bone at the bottoms of draws, and then try to work your way up the hill to find where the source is. The tools we use out here are common ordinary tools, shovels to begin with, whisk brooms and 2-inch brushes. We don't like to brush the fossil directly with the heavy whisk broom. We use a smaller, more delicate paintbrush. We use hammers, screwdrivers, chisels, dental picks sometimes, especially for small things like teeth. And what we try to do is remove the dirt so that we isolate that bone and get down below it, and then uncover it, coat it with a protective layer of Vinac. Then we put a plaster jacket, a cast on it, just as if you broke your arm. It just stabilizes it. Then when we get that jacket, we roll it over in the field, pick it up, if it's small enough, by hand. If not, we need heavy equipment to pick up the jackets. And we transport them into the lab.
Once back in the lab, volunteers and paleontologists work together to remove the remaining rock and matrix from the fossils, using tools and methods pioneered by early paleontologists.
Well, we still use the hammers and screwdrivers as chisels. Screwdrivers are usually more delicate than an actual chisel. But then we get down to air scribes, and we have 2 or 3 different strengths of air scribes. And they sound a lot like a dental drill, but they're actually a little hammer. And we get down to the bone. Hopefully the matrix will separate from the bone. And we use dental picks for small areas and carbide tips. Then we have to start using the consolidants and adhesives.
Once these specimens are put together and cataloged, they either become part of an exhibit or are stored in the collection room at Dinosaur Journey, where both the public and scientists have access to them. Modern techniques developed from new technology are also now becoming commonly used in paleontology, such as CT or CAT scans.
So CT scanning itself is a very simple technique that involves a rather large and expensive machine. The technique itself is just X-rays. Certain rock that contains fossils X-rays very well, and the object sits on a rotating platform, and you take multiple X-ray photographs of this thing as it slowly rotates. Sometimes you take 3,200, 5,000 different pictures. And the computer reconstructs all these X-rays into a 3-dimensional image that captures the entire volume of the fossil and the surrounding rock. But the power of this, of course, is that without doing any mechanical preparation that takes time and could damage the bone, you can produce a floating digital image of the skeleton, free from all surrounding rock.
The earliest fossils of dinosaurs in the Grand Valley are from the late Triassic Chinle Formation and the Wingate Formation, which preserves the Triassic to Jurassic transition. This transitional time is interesting because it represents 2 very different ancient environments. The Chinle was a very wet time, with remnants of ancient rivers, lakes, and floodplains, while the Wingate was a dry, sandy desert environment. Above the Wingate is the Kayenta Formation, a thin rock layer that represents streams and floodplains that overtook the dune seas of Wingate sandstone. Above this is the cliff-forming unit of the Entrada Formation, representing another dune sea environment that covered this area in the Middle Jurassic period. Not all fossils are hard bones of ancient skeletons. Tracks and trackways from the late Triassic and early Jurassic are also common fossils on the western slope.
All of the sandy desert deposits in this part of the world, going from the Triassic to the Jurassic in particular, seem to be dominated by tracks of very small animals, and many of them are sort of mammals or mammal ancestors, no bigger than rats or maybe the size of a house cat. We find dinosaur tracks as well. Growliter is one of the most famous tracks of a small carnivorous dinosaur. They're usually anywhere from about 3 to about 6 inches long. They have 3 toes, which are very bird-like.
Studying tracks and trackways helps scientists understand aspects of ancient creatures which fossil bones cannot tell us.
If you have, say, 6 or 7 rock formations up through time, like you do in this part of the world, what you'll find is 3 or 4 of them don't have any bones at all. So the tracks really help to reconstruct the ecology and the fauna in areas where bones are missing. And studying tracks is much more dynamic because you're dealing with the evidence of the living animals. It's a window into behavior.
The Morrison Formation was deposited in the late Jurassic period and is a huge rock unit that extends from New Mexico all the way to Canada and east-west from Utah all the way to Nebraska. It really is North America's original Jurassic Park and preserves some of the richest dinosaur quarries in the country. The largest assemblage of dinosaur bones in the Grand Valley can be found in the upper layers of the late Jurassic Morrison Formation.
If you were to go back into the late Jurassic period and take all of the Morrison Formation and give it one depositional environment, you would call it a big river system. It would be the equivalent of the modern day Mississippi River Valley. Overall, it is a river system, but in that river system, there are lots of microenvironments. You have river channels, you have floodplains, you have deltas, you have lakes, and you also have salt flats and marshes. And all of these different microenvironments together make up the different rock units within the Morrison Formation.
On the western slope of Colorado, 2 areas within the McGinnis Canyons National Conservation Area stand out among the other quarries in the Morrison Formation: the Fruita Paleontological Area and the Mygatt-Moore Quarry. With about 24 different sites, the Fruita Paleontological Area tells an interesting story of the evolution of the small animals of the late Jurassic. An active research area today, the Fruita Paleontological Area was first put on the map with the discovery of microvertebrate fossils. The paleontologist George Callison came to the area from Cal State Long Beach in 1975.
I was interested in particularly the origin and early evolution of snakes, and I wanted to go someplace where I would have an opportunity to find skeletal material from small animals. And so we came out west to see if we could discover something, and saw some very nice expanses of badlands that have low-angled slopes that can be easily crawled, lots of exposure, and so we thought this might be a good place to look. Our usual procedure in trying to discover fossils of small vertebrates was to come into an area, look at anthills, crawl the anthills and see if they had picked up anything, and then start walking the outcrops, looking at these sediment pans. So that then led us to places to begin digging. and many of the specimens came from one level, and that led us to doing more extensive excavation of that level. The work here at the FPA, I think, revealed to the paleontological community a number of things. One of them is of really great general value, and that's the value of hand quarrying. By crawling carefully around on the landscape and discovering where the specimens are coming from and then hand quarrying them, we were able to find complete skulls, complete jaws, complete skeletons, specimens that are of such high quality that we can make a lot of sense of what they are, who they're related to, what they did for a living, and those sorts of questions that couldn't just be answered by finding fragments. Anytime you come across an articulated skeleton, it is surprising because there's so much that happens to an animal after it dies that prevents it from becoming a fossil, let alone the entire skeleton being preserved. And yeah, we were thrilled. We were so thrilled, in fact, that we thought that this merited some really long time work. And we began getting other paleontologists interested in it.
The discoveries and specimens coming out of the Fruita paleontological area represent an entire diverse community of animals that lived with the large dinosaurs. Small crocodilomorphs like Fruticampsa, sphenodonts, which are lizard relatives, small mammals, and dinosaurs like Frutidens. Frutidens was a small bipedal dinosaur about the size of a chicken. Its discovery was significant because at the time it wasn't believed that an adult dinosaur could be so small. Another important discovery in 1998 by Wally Windscheffel was Frutifossor. It took over 2 years preparing the fossil before it was recognized as an important new discovery. A unique creature because it had features that went extinct and then re-evolved in the modern armadillo. One of the most unique sites in the Fruita paleontological area is a site called the Kirkland Egg Site. It is the only site in the entire Morrison Formation where there are remnants of dinosaur eggs and the bones of the animal that was laying the eggs, a small bipedal herbivorous dinosaur called Dryosaurus. The museums of Western Colorado began working in the Fruita paleontological area in 2004 and continues the work there today. Visiting scientists are drawn to the area because of the unique diversity of specimens representing the late Jurassic period.
We just know so little about these groups. We know much more about the dinosaur groups than we do about the early history of these modern groups. The history of life is incredibly dynamic, and that these aren't all dinosaurs, and that to understand the modern ecosystem, the way that animals and plants interact with their environment today, is we need to know the history of that, and it's places like this that we can uncover that history. This is the best place for finding these kinds of animals.
Nearly 20 miles west of the Fruita paleontological area, in the heart of Rabbit Valley, lies the Mygatt-Moore Quarry. The 1981 discovery is attributed to Pete and Marilyn Mygatt and J.D. and Vanetta Moore. Pete and J.D. worked the quarry for 2 years, and then, in 1985, former curator of paleontology at the Museums of Western Colorado, Harley Armstrong, began work at the quarry. Since then, it has been worked every summer season, and the Museums of Western Colorado has recovered well over 5,000 bones. Like the Fruita paleontological area, Mygatt-Moore lies within the boundaries of the McGinnis Canyons National Conservation Area. But this quarry tells a different story of life and death in the late Jurassic period.
As far as we can tell, the Mygatt-Moore Quarry is a seasonal pond. It probably did not have water in it more often than it did. There is a lot of plant material in the quarry that we find today. It's all carbonized, and at least 15 different species of plants have been found here. A lot of the diversity is in the conifers, and we also get a lot of horsetails. That suggests to us that it had a lot of vegetation, probably year-round. But the lack of fish and the extreme rarity of crocodiles, turtles, and other aquatic animals suggests that there was very rarely standing water here. We suspect that there was a high water table here that allowed animals to access water year-round, and vegetation grew here pretty heavily. But still, the diversity here is pretty low. There are only 7 types of dinosaurs found here, and only 2 of them are actually common. Allosaurus is the most abundant, big carnivore. Almost equally abundant is Apatosaurus, which is a big 70-foot plant eater. After that, we have Mygatt-Moore Quarry, Diplodocus, Camarasaurus, Ceratosaurus, very rare, only known from teeth, and we have a single jaw fragment of a small bipedal plant eater called Othnilosaurus. There are a lot of shed teeth of carnivores that we find in the quarry. These were things that fell out of the animal's jaw as they were feeding. Another line of evidence that suggests that is we get a number of chewed bones in the quarry. So we know that carcasses were being scavenged. We don't know the animals were necessarily being killed here, but we know the carcasses at least were being fed on.
One of the 7 dinosaurs found in the quarry, Mygatt-Moore Quarry, was first discovered by Dr. Jim Kirkland at the end of the field season in 1989. Working with a small team, he found bones and fragments of armor from the dinosaur. This exciting discovery was the first ankylosaur found in the Morrison Formation.
One of the coolest things about the Morrison Formation is that even though researchers first started digging fossils out of it in the 1860s, we're still making new discoveries almost 150 years later. One of the largest new finds that we've had was discovered in 2010. The crew was trying to excavate out a large vertebra, and as they were digging around the vertebra to isolate it from the rock, they ran into this lump of bone. And then they ran into another lump of bone. And these 2 lumps formed the knee part of a femur. And it took 5 summers of digging to isolate the femur.
Once removed, this femur, with its plaster cast, weighed 2,800 pounds and measured 6 feet 4 inches in length. It is easily one of the largest, most complete Apatosaurus femurs ever found.
Apatosaurus is a large herbivorous dinosaur with a long neck, long tail, belongs to the group called Sauropoda. And this femur, if you were to take the measurement and do the math, the animal would have been about 90 feet long. The average size of an Apatosaurus is 65 feet long.
The quarry is so plentiful that Mygatt-Moore has become a place where visitors can be paleontologists themselves and help excavate dinosaur bones with the experts from Dinosaur Journey.
The museum started doing a public dig program out here in the late 80s, and we bring groups out here 2 to 3 days a week during the summer, and we usually have young families that come out and they help us excavate the material. It gives everybody a taste of what the work is really like. They see not only what the excavation is like, but what all is involved in recording all the data and in doing everything that we need to do to try to answer the questions that we have about the site.
The Cretaceous period, which lasted from 145 to 66 million years ago, was the staging ground for many of North America's most iconic dinosaurs, including the raptors, Triceratops, and even Tyrannosaurus rex. On the western slope, several geologic formations from the Cretaceous period can be found. Above the Morrison Formation lies the Burrow Canyon Sandstone, and on top of this is the Dakota Sandstone. The Main Coast Formation forms the base of the Book Cliffs, and above this is a group of several rock units called the Mesa Verde Group, which forms the cap of the Book Cliffs. These Cretaceous age deposits represent oceanic environments, when a vast inland sea stretched south from Canada into the western interior of North America, dividing the continent into an eastern landmass known as Appalachia and the western landmass called Laramidia.
This seaway advanced and retreated multiple times during the Cretaceous period, and the Dakota Formation really represents the rivers and streams and beach environments that were near but not part of that western interior seaway. The Main Coast Formation is also part of that western interior seaway. It represents a deep water environment. So this would have been a period of time when the Grand Valley was completely submerged underneath the western interior seaway during the early Cretaceous period. We find lots of marine animals in this formation. We find mosasaurs, plesiosaurs, ammonites, sharks, and of course lots and lots of clams.
North of Grand Junction, in the Williams Fork Formation, part of the Mesa Verde group, dinosaur fossils are plentiful in the rocks of once ancient swamps and deltas. No matter in which rock formation fossils are found, paleontologists must always be aware of where they are excavating. Sometimes fossils are found on private land, and permission to excavate and remove fossils must be granted by the landowners. However, in western Colorado, many fossils are found on public lands managed by the United States Bureau of Land Management. In these cases, special permits and care must be taken in collecting fossils. Within McGinnis Canyon's National Conservation Area, there are several locations with interpretive trails, as well as several active quarries.
The Paleontological Resources Preservation Act that was passed in 2008 by Congress, and it's a law that protects vertebrate fossils and other important fossils on public land. So it requires that to remove vertebrate fossils or other important fossils on public land, you have to have a permit from the Bureau of Land Management. And we normally only issue those permits to scientists and museums so that they can study those fossils and we can learn more about the history of the earth that we live on. Also, it usually requires the museums to have a curation agreement so that they will show those fossils to the public in the future so that people can view the fossils that have been found on their public lands. Well, McGinnis Canyon's National Conservation Area has several interpretive trails. Dinosaur Hill, Trail Through Time, and Fruita Paleontological Area all have interpretive signs showing fossils in place where they were deposited. There are quarries out at Mygatt-Moore in Rabbit Valley and as well as Fruita Paleontological Area. Or you can just be hiking out on public lands and find fossils on your own. If you do, we hope that you'll leave them in place. Take photographs, maybe take a GPS point and provide that information to the Bureau of Land Management or the museum. But leave them in place so future visitors can enjoy those fossils as well. You know, the research being conducted at Dinosaur Journey is very important to our understanding of the world that we live in and the history of the earth, and the Bureau of Land Management is really proud to partner with the museum to bring these fossil resources to the public.